Hello, what is this? What is going on?
I can't just keep sitting here watching this.
Why don't you start the next part of your course?
I'm waiting for young me to get back. Why is he never here?
You keep sending him out for food.
That's beside the point as I move. Like I said, I can't just keep sitting here watching this. We have to do something about this robot.
It was your meddling with him that gave him the ability to speak.
What is going on?
Look, Eve, listen. I'm very sorry that I gave you a voice with my future science. I really am.
I understand.
Good. I think we're going to need to start the episode without young me today. There's a few things I'm going to need to teach you, Eve, if you're ever going to hope to mix in with the human world.
Like what?
Well, most people don't repeatedly walk into boxes over and over again.
I understand.
Oh, don't be like that. Come on, cheer up. Look, I'm going to get on with today's episode, and it's going to be all about teaching you a few more human tricks. You know, things to help you mix in with regular people a bit more and make some new friends.
This sounds positive.
Good, so let's go. Welcome back, kids, to another episode of Magic Made Science. I'm Dr. Victor Drone, and welcome to part 4 of my LEGO Mindstorms course. Today's subject is inputs.
Input. A place where or a machine through which energy or information enters into a system.
Indeed. An input is a piece of hardware. You may remember from the previous episode that hardware refers to any equipment to do with a computer that we can see and touch. An input receives information from the outside world and sends it through to a computer, just like the information in every program that we feed into Eve's P-brick. But it also applies to something as simple as buttons on a keyboard or as complex as a fingerprint scanner. So to summarize, an input is a device through which information is communicated from the outside world and into a computer. And he has no input, meaning he can't see or feel anything. He doesn't know when he's walking into walls over and over again. Have eyes and fingers, we will be able to make it so that you can see and touch, in a way. With the use of inputs, we will be able to make it so that Eve can feel things kind of like a human being. I think it's about time that we gave Eve some sensors and taught him how to use them.
Sensor. A machine which detects or measures a physical property and records, indicates, or otherwise responds to it. Sensors are a robot's eyes.
A sensor is basically something which allows a computer to interact with the outside world. A sensor is a machine which can detect things like light or touch. You will find your Everstorm's touch sensor inside your Everstorm's box. It looks like this. What you want to do is attach this sensor to your Everstorm's hand. Eve's touch sensor works like a button. Eve reacts to it when it is pushed. This is going to have a lot of uses for you, Eve. You're going to be able to sense a wall by detecting it before you run into it. But first, we're going to need to teach you how to handshake, because that's a way that a lot of people greet each other in this time. So, in order to follow my instructions, kids, ensure the touch sensor is connected to input 1 on Eve's P-brick. Your Everstorm's input ports can be found on the bottom of the P-brick. Remember, they are numbered, unlike the output ports for the motors. Like I said, I was going to teach you how to do a handshake, but then I realised no one handshakes in this time, so let's make it a cool fist bump.
I understand.
So let's get our laptops and our Everstorm robots ready, and I'm going to teach you a program to help Eve do a fist bump. Welcome to Touch Sensor Academy. Okay, so you want to start out with a new project. I'm going to call this one Fist Bumping. So, this program is one that's going to need to be constantly looping to work, otherwise we'll only get one fist bump out of it. So, as before, we need to start off by building everything inside a loop block. If you go to the orange tab, which is the flow controls, you can select a loop. This is the ordinary loop block. If we place that at the beginning of our set of commands, you will see it is automatically set to infinity, meaning it will continue looping forever. This means the computer will be constantly repeating the program we place inside it, which will be the program responding to the touch sensor. We are now going to add one of the other types of loops. This is called a switch loop. This is going to be the basis for our program. So first we must place this inside our standard loop. This loop allows your input to affect the program whilst it is being run. It's a way for the computer to make a decision. In this episode, we are going to see a lot more of how Eve follows programs like a flowchart, beginning at the top and following the path set out by the commands, like a train on a track. The switch block is like the switch on a set of railway tracks. The switch block provides two different sets of commands for Eve to follow, like the two different routes where the track splits. Eve always follows one set of commands on the switch block until an input is received, like flipping a lever. Then the track changes and the other set of commands becomes the new sequence Eve follows. The sequence is completed and the loop begins again, Eve's route the next time around depending on the position of the switch. In this case, we're using an input that is not a switch but a button. Once the button on Eve's touch sensor is pressed and released, the sensor interprets this as information and sends it to the computer, flipping the switch. The program, and thus the computer, will then follow the second set of commands until the button is bumped again. First, you want to make sure the input the switch block is being controlled by is the touch sensor. You can set that by going to this drop-down menu here and going to the touch sensor option. Then the option compare and then the option state. So now if we go to this option menu here, we can see that there are three settings. If you hover your mouse over them, you'll see that option 0 is labelled released. This means the switch will change the program when the touch sensor is released after being pressed down. Option 1 is pressed, so the program will change when the touch sensor is pressed down. And option 2 is bumped, meaning when the sensor is quickly bumped, it will change the program. That's the one we want for a fist bump. This top half of the switch block, marked with a tick, is the set of commands that will be followed when the touch sensor is bumped. The lower half of the switch block that is marked with an X is the set of commands that will be followed when the sensor is not bumped. This sequence of commands is Eve's default track until the touch sensor is bumped and the switch is thrown. Then Eve will follow the new track. So when I fist bump Eve, he will need to react, preferably with a smile. Otherwise it's just rude. I mean, why would you not smile? What's wrong with my fist bumps, Eve? So, we will need to add an image of a smile for Eve's display. To do this, you will need a display block. This is one of the action blocks found under the green tab. So, once you have placed the display block up in the top half of your switch block, you will see on this tab that it is automatically set to image, but the display can also be used for text and shapes. When the display block is set to image, you can go to this tab in the top right-hand corner of the display block and select from the file an image you want to show on your Everstorm's display. We want Eve to smile, so we should go to the expressions, and the first option, big smile, sounds ideal. So, click on another part of your screen to close that menu. We should also have Eve saying something when I fist bump him, to mark the occasion. My fist bumps are famous. So we should add a sound action as well to the top half of the set of commands. Make sure it is inside both the regular loop and the switch loop. And again, if you go to the tab in the top right hand corner of the sound block, you can select from some preset sounds. So if you go to the communication menu, you can choose for your Everstorm to say hello or hi. Personally, I prefer random animal noises, so I'm going to go with the dog bark one. Now we need to set the sequence of commands for when Eve is not being fist bumped, and we only need one command block for that, and it's another display block. So, just like before, place the display block in your set of commands and go to the tab to select from the preset images. We want Eve to look normal when we're not fist bumping him, and he is already a bit miserable most of the time anyway, so we'll go with a sad face. That'll make him look normal. And there we have it! The program is done. There is no need to set any duration on any of these commands as the loop keeps them repeating constantly. So the switch is repeatedly being run through by the computer, going down to this series of commands, and now, when the touch sensor or switch is bumped, the program will switch to this set of commands and back. So now the program can be downloaded into your Everstorm's pbrick, and just like before, it can be selected using the graphic user interface, or in regular words, on Eve's pbrick. So, let's see our program in action. Eve, prepare yourself for the most incredible fist bump in future history. Yeah! Hey, that's the end of another section. Make sure you download the PDF and do your learning objectives. See you in a sec.